Hi students, welcome back to mathematics class. Yes, with me I have the students of North Georgetown Secondary School. Are you happy to be here again?
Yes, sir.
All right, good, and I'm happy to work with you. I did enjoy my last class. Did you enjoy it?
Yes, sir.
Good, and we look forward to enjoying this class. Now, let's just jump straight into the maths. You know, I really want to get on with the maths. I get excited whenever I'm doing maths. Do you get excited?
Yes, sir.
Good. The last class, we just brushed on this topic, you know, we barely touched on it. Subsets, right? And we show what the subset, what is a subset of another set and so on. But today we're going to go a little further into this topic, and we're going to look at the number of subsets in a given set. Right? So if you're given any particular set, how do you know how many subsets you could get out of this particular set? All right?
Sometimes it depends on the amount of elements that makes up the set.
Yeah, the amount of elements that make up the set. Yeah, you know, imagine if a set has 100 elements. You can imagine how many subsets you could get out of that set. A large number, right? And while we can list the subsets of a set, for example, if we have the set P equal to 2, 3, 4, we can list some of the subsets of this here. So help me list the subsets. What would be one subset?
2 by itself.
Just a moment. Good. Yeah, that's good. The empty set, 1,
2,
The set with the element 2,
3,
Continue.
4,
Good.
3,
Oh, so now we're listing in pairs now.
2 and 4,
Yeah.
2 and 4,
2 and 4. Any other pair?
3 and 4,
Good. You have any other pair?
No, sir.
All right. Any other subset there?
2, 3 and 4
You sure 2, 3, and 4?
altogether.
But 2, 3, and 4 is the set itself.
Yes, sir. You don't
So you
go back
have
any
to put
last.
it back in.
Why? But no, you see the thing in maths, you don't just do things because somebody, you have to know why. So why would we list? I will list it and you tell me why it's correct. 2, 3, 4. But this is the set itself, so why do we still have it as a subset? Let us see. How did we define set in the last class? A subset, sorry. How did we define it in the last class? We said, it's a set for which all its elements can be found in the other set. So, can we find all the elements of this set in this set here?
Yes.
So then this is a subset of that. Can we find all the elements of this set in that one?
Yes,
Yes,
sir.
So that is why this is also a subset of that. All right?
Yes, sir.
So next time, don't just say, we just usually write it. You can explain why. We write it because all the elements here are there. So it is also a subset. So that's why every set is a subset of itself. Now we can list these here. Now look at this. We have 2, 4, 6, 8 subsets for a set with 3 elements. Now I was told that North Georgetown Secondary School has about 600 students. So do you think you'll be able to list all the subsets for a set with 600 elements? That would be quite a tough task, huh?
Yes.
But if somebody asks you how many subsets can we have from a set with 600 elements, as a mathematician like you know you all are all mathematicians, right? And you got to get better at being mathematicians. As a mathematician, you must know how to calculate this. So let us do an experiment quickly to see if we can come up with a generalized way to find out the number of elements in a subset. So let us start with a set of 1 element. The set with 1 element. So if we have P equal to the set with the letter C. What are the subsets of P?
Empty set.
We have the empty set,
and 3.
and we have the set
3.
C. So, a set with one element has
2 subsets.
two subsets. Let us find out about the set with two elements. How many subsets you think it will have?
3.
All right, we will find out. Let us see. If Q is equal to the set CD, the subsets,
Empty set.
let us see, the subsets are
Empty set.
the empty set,
C.
the set with the element C by itself, yeah,
D.
the set with D, and the set with CD. So we see with when the number of elements in the set is 1, we have two subsets. When the number of elements in the set is 2, we have 4 subsets.
6.
6. 5, 6. Let's find out, man. Let's find out. Because remember, we want to generalize something so everybody could use this as rule, as true. And we don't want to give people wrong information. So let us generalize. If R is equal to the set C, D, E, the subsets of R good? I know you will tell me the empty set.
Yes, sir.
And then we will have the sets with one element. C, D,
E.
E. Then we're going to put them in pairs. C, D,
D. C.
Let's list C, E first. So we finish with C, yeah? Then we go to D, E. Any other? Then we have the set C, D, E. So are there 5 subsets? Are there 6? How many?
8.
8. So let's see if we can follow a trend now, man. So if n represents the number of elements, right? So if when the number, let's denote it as when n is equal to 1, we had the subsets equal to 2. When n is equal to 2, we had the subsets equal to 4. When n is equal to 3, we had the subsets being totaling to 8. When n is 4, I want you to tell me this without us having to do it. When n is 4,
16.
16, good. And when n is 5, 32. Let me push you farther now. When n is 6, now let's see if they know their tables. 64. Good, correct. So at least we be following the trend. So let me write this in here. The subsets will be equal to 16. So let us just see what is happening here. 2, 4, 8, and 16. 2 is the same as 2. 4 is the same as 2 times 2. 8 is the same as 2 times 2 times 2. And 16 is the same as 2 times 2 times 2 times 2. Now, how many 2's we have here?
4.
And how many elements in the set?
4.
How many 2's we have here?
3.
How many elements in the set?
3.
So we follow what's happening. So for example, if n is equal to, let's say, 7, it therefore means the number of subsets will be 2 times 2 times 2 times 2 times 2 times 2 times 2. Do we have 7 2's there? Huh?
Yes, sir.
Yes, we have 7 2's here. So it therefore means the number of elements, the number of subsets in a set with 7 elements will be equal to, help me calculate, man. You brighter than me. 2 twos, 4 twos, 8 twos, 16 twos, 32 twos, 64 twos. Very good, students. 128 subsets. All right? Now, again, this look too long. As mathematicians, we have to find an easy way of writing things. So, you did indices, right?
Yes.
Laws of indices. So, for example, we know that this is the same as 2 to the first power.
Yes.
It's 1, 2. When we have 2 multiplying by 2, it is 2 to the second, 2 to the third, 2 to the fourth, 2 to the seventh. All right? So let us set up this general thing over here now. So what we have is, when n is equal to 1, we have the subsets totaling to 2. When n equal to 2, we have the subset totaling to 2 times 2, which is equal to 2 to the second. When n equal to 3, the subsets being 2 times 2 times 2, which total to 2 to the third power. When n equal to 4, it being 2 times 2 times 2 times 2, which is 2 to the fourth. When n equal to 13, what will it be? All the way across it, this will be 2 to the... Come on, y'all afraid? Shout it out. 2 to the 13th power. All right? Mustn't be afraid of your intelligence. You know it's 13, so just say it's 13. All right? Good. So we see that whatever n is, n representing the number of elements in a set, whatever n is to determine the number of subsets, we just raise 2 to that amount of power. Is that clear?
Yes, sir.
Good. So in the set, let's just consider an example now. In the set S equal to A, B, C, D, E, F, G. How many elements we have here in this set?
7.
We have 7 elements. So imagine somebody come to you with these and they want all the subsets. They want to know how many subsets, but the poor person don't know mathematics. So they come to you, the mathematician, and they say, look, come help me, man. I want to know how many subsets I could get from this. Right? They come to you now. So let me see how you're going to help them out. What will you tell them?
2 to 7.
2 to the
7.
7th power. So we say the number of subsets of S is 2 to the 7th power, which is, we multiply just now 2 times 2 times 2 all the way 7 times until we get to 128. So in general, if a set has n elements, then there are 2 to the n number of subsets. If a set has n elements, then there are 2 to the n number of subsets. Is that clear?
Yes, sir.
All right, but I have a job for you. How many subsets can we get from this class? Let me see the first person to tell me. Work it out in your book quickly and tell me. Or if you know the answer, just push up your hand and tell me the answer. I don't need 2 to any power. I need the actual number. You have 5 seconds. 5, 4, 3, 256. Give him a clap. 256, correct. Lovely. Why 256 now? Come on, explain to the class why 256.
Sorry, guys. You put 2 to the 8 power.
Stand up and explain to the class, man.
Sir, 2 to the 8 power 9 multiply.
Why 8 power?
It has 8 students.
8 students. Good. So the set has 8 elements. So we say 2 to the 8th power. And then we multiply 2 by itself how many times? 8 times. It's not 2 times 8, but it's 2 by itself 8 times. And 2 twos, 4 twos, 8 twos, 16 twos, 32 twos, 64 twos, 128 twos, 256. Right, students. Good. Congratulations. All right, you may take your seat. Good. So from today, this is what you're going to do. When you go home, you could check with your family how many members in your family and see how many subsets you could get. Check with your pets, see how many pets you have and see how many subsets you could get. Everything you go, you could see. When you jump in the bus, count how many persons in the bus and see how many subsets you could get with them. All right? And you do that from when you leave here and until you reach home. You just find as many subsets for things as possible. All right? Yes. Good. So we come to the end of this lesson on finding the number of subsets in a given set. Did you enjoy today's lesson?
Yes, sir.
Well, I enjoyed it myself. And guess what? I look forward to seeing you again for another class. So until then, you take care. Subsets, go and find out about subsets.